Hi, my name is Liz Thompson, and this is a video for IME 315, Financial Decision Making for Engineers at Cal Poly San Luis Obispo. This video is the first video on material cost. And when we look at the 5 areas that we're covering in this class, this is a concept associated with the cost of products. So in the previous video, we talked about fully allocated cost as being composed of 3 types of costs: labor, material, and overhead. And we compare that total cost to the sales price, and that's going to be a profit per unit analysis. In this video, we're going to be talking about material costs. So what are the quantity of raw materials is needed to make this product, and how much does the raw material cost? So when we talk about the cost, it's a kind of a per unit analysis, and we need to understand things like quantity discounts and the return for recycling. We're going to talk about recycling return, not so much about quantity discounts, but that needs to be considered when you're calculating the raw material cost. We also want to know how much is used, so not just the cost, but how much. And so a lot of this is a unit analysis, but we also need to make sure we're accounting for things like waste and scrap and rework. So the basic equation that we use is this equation. M, which is the per unit cost of materials, is equal to R minus V, where R is the cost of raw materials. V is the recycling, the revenue from recycling, and then you take that and you divide it, you divide N into that, which is the number of good units in a batch. And a batch can be defined many different ways. I have another video where the definition of a batch is a little bit different, but in this video, we're going to be looking at this particular problem where we have a 6-foot length of 1 1/17 inch cold rolled steel bar stock. So that's going to be define the batch that we're going to be producing. How many units are we getting out of this 6-foot length? And it weighs 5.51 pounds per foot, and it costs 80 cents per pound. And you can see the dimensions. What we're going to be doing is we're going to be cutting pins off of this cold rolled steel bar, and there's some portion that's going to be lost to the collet grip. And then there's some portion at the end that is not going to be enough to make one more pin. In addition, there's an 1/8 of an inch that's lost to the saw when we cut this off. So those are the dimensions of the thing that we're trying to process. So when we look at the equation, the question is, we want to know what R minus V over N. And I'm going to start with the simplest version where we don't get any revenue from recycling, or V is equal to 0. But we still need to calculate what's the cost of the raw material associated with this bar stock, and how many good parts do we get out of it. So the cost of raw material is just a unit analysis. It's 6 feet times 5.51 pounds per foot times 80 cents per pound. And that means that total 6-foot length of bar stock costs $26.48. And we always need to make sure that we have a unit analysis correctly, and so I included that on that calculation. So it's $26.48. And then the other thing I wanted to really point out here is when you keep as many significant figures as you can in calculating, and most of the time your calculator can handle that, or if you're doing an Excel, it can keep as much as you want. But then at the end, we need to round to indicate the precision of the estimate. So this estimate's pretty precise because we know how much it weighs a pound and we know how long it is. So we can keep this many significant digits. But in the end, we need to be cognizant of what is the precision of our estimate. So let's go ahead and make this, we need to also calculate the number of good pins. So what happens is this is a 72-inch length of steel bar, and we know there's an inch that's lost to the collet grip, so that means there's 71 inches that are available to make the pins. The pins themselves are 1 1/8 inch, and then there's an 1/8 of an inch that's lost to the saw. So if we just do that calculation, it ends up to be 56.8 pins that we can make out of this barstock. But we know a 0.8 of a pin is not a useful pin, so we are going to round that down and say each barstock will make 56 good pins. So then we just do this calculation, 26.4846, minus 0 divided by 56, and that gives us the cost of raw material at 47 cents, $47.297 per unit. And that's going to be our value. Now we're going to make this a little more complicated and say that there's some scrap. That means that when we're cutting the pins, that 5% of them are not to tolerance. So we need to include that in the calculation. The cost of the bar stock is the same at $26.4864, but the number of good parts is not. So before we had 56 parts, but now 5% of the 56 units are bad. That means we take 56 times 1 minus 0.05, and that means that they're going to be 53.2 good parts coming off of this bar stock. Now, I'm not rounding that, and I think we need to think a little bit by why am I not rounding that down to 53 units? And it's because that this is on average. We're doing this over and over and over again. And there's never 53.2. Sometimes there's 53, sometimes there's 56, sometimes there's 52, but on the average it's 53.2. And so we're going to use that average number to do the calculation. So now the cost of this raw material has gone up. It's now $49,786. And that's because we have some bad units that we can't use anymore. And so those that cause the cost per unit to go up. Now, again, we're going to complicate it a little bit more and say all metal can be recycled at $10 10 cents a pound. So now the question is, how much is recycled out of this particular batch? And there's a lot of ways to figure that out, but the easiest way, in my opinion, is to take the total weight of the bar, which is 6 feet times 5.518, which is 33.108 pounds. And we know the good pins are 53.2 times, and we're going to put this in feet. So where the good pins are 1 1/8, and we're converting that to feet by dividing by 12. And then we're multiplying it by the weight per foot. So we know that out of the 33.108 pounds, 27.521 was good product. That means just by difference, the waste was 5.587 pounds, and we get 10 cents a pound for that. So that means we're going to get 55.87 cents. So we plug that into, and we remember our old values, and we plug that into the equation. And what ends up happening is we have now the cost actually fell because we subtracted out that revenue from recycling. So let's look at overall here. We initially had the costs before we had recycling and before we had bad parts at $47,297. Then we added this 5% scrap rate, and that ended up increasing the cost per unit. So it went from 47.3 cents to 49.8 cents. And that's because we had some bad pins. So you can see the cost of quality can be reflected in these calculations, or cost of bad quality. And then we said, well, we're going to be recycling. So that ended up actually lowering the per unit cost from the 49.8 to 48.7 cents. And that's because we're getting revenue from recycling. We're getting some money back in the system. Now, let's review this again. This is the equation. You might want to make sure you jot this down because it's an important equation when we look at material cost per unit. So we want to look at, in this case, we looked at the entire cost of the 6-foot bar. We looked at the number of good pins on average come out of that 6-foot bar. And then we looked at the money received for selling scrap from that 6-foot bar. And that's how we ended up doing this calculation, because we defined a batch as a 6-foot bar. And that's really important to really get that definition of a batch down. It doesn't actually matter how you define it. You'll get the same get the same answers. It's just that some ways are easier to calculate than others when you're defining a batch. In this case, it's much easier to define a batch as a 6-foot bar. We'll do a calculation where we define a batch as 1 item or 100 items, and we'll do it a little bit differently in the next video. So this is a video that covers the cost of product, particularly material costs.